Welcome, developers, to this explainer on governed actions with AI Fabric. Today, we're diving into exactly how we take a user's natural language request and safely translate that into a verified, authorized, and confirmed database transaction. If you've ever laid awake at night worrying about giving an AI model the keys to your database, well, this is exactly what you need to see.
Our mental map for this journey covers 5 steps. 1. Requests, not database commands. 2. The executable action registry. 3. Validation and authorization gates. 4. Backend-owned confirmation state. And 5. Owning the domain change.
All right, let's jump straight in to Section 1, Requests, not database commands. Think of AI Fabric as a highly trained bouncer sitting right between your application and the AI models. It acts as our central coordination layer. The entire philosophy here is simple but absolutely crucial. The framework ensures the model merely proposes an action, but the Spring Boot framework and your application, they actually govern and execute it.
The old, frankly terrifying way to do things treats an untrusted LLM's natural language output as a direct, autonomous database command. No thank you. AI Fabric completely flips this paradigm. It requires a safely filtered, governed action proposal. So, the model proposes an idea, the framework validates it, and only then does the application execute. It's a massive shift in trust.
Which brings us to Section 2, the Executable Action Registry.
Now, how do we restrict what the model even knows is possible? Well, the AI Action Registry acts as this airtight executable allow list. On startup, it actively discovers your @AI Action Spring Beans. It's incredibly strict too. It requires exactly one action execute method per action, and it instantly rejects any duplicate action names. So, let's say the LLM hallucinates a method name or tries to guess an endpoint, bam. It hits a solid brick wall and the framework instantly returns an action not found error. The architectural golden rule here is literally this. The model chooses among reviewed possibilities. It never expands the set of possibilities. It's exactly like handing the model a tightly constrained restaurant menu. It can pick what it wants, but it is entirely forbidden from ordering off menu.
Moving right along to Section 3, Validation and Authorization Gates.
Before anything actually executes, everything goes through a rigorous pre-execution pipeline. First up, we have schema validation using @param boundaries. Second, parameter binding kicks in, safely translating the model's proposed values into strict Java types. If a value is missing or invalid, it doesn't just crash or try to guess. It actually pauses and returns a clarification request to the user. Finally, we hit the @ActionAllowed gate. This is where strict Boolean checks verify your domain-level authorization before we go a single step further. Now, a quick pro tip, and honestly, we kind of have to laugh at the alternative. Never, ever expose server-owned data like identity, tenant IDs, or active subscriptions as @param fields for the LLM to fill in. I mean, you're basically teaching the model to ask the user for data the server already securely owns. Always derive canonical identity from the trusted backend using action context.
Okay, Section 4, Backend-owned confirmation state. What happens when an action needs the user's explicit blessing?
AI Fabric handles this with what we call a pending action. Think of this as a backend-owned conversation state. It literally holds a paused, fully validated action proposal, just waiting for user approval. And because the framework creates this pending state safely in your backend, we know confirmation isn't just some flimsy UI button click that a bad actor could bypass. It's a deliberate, highly secure orchestration pause. Here's how this two-turn flow protects your data in practice. Turn 1. The model proposes the action. AI Fabric saves that pending state in the backend and returns a confirmation required signal to the client. Turn 2. The user inputs yes. Because we saved the state securely on our end, this flow absolutely guarantees we're executing against an immutable backend state. Zero duplicate processing, zero front-end manipulation.
And finally, Section 5, Owning the Domain Change.
After clearing every single gate, the framework steps back. It hands the reins over to your Spring Boot handler. The registered @ActionExecute handler runs and invokes your real domain service. So, your application fully owns the transaction and the idempotency. The only catch? You must return a structured action result or action payload. AI Fabric requires this clean, structured result because we absolutely do not want to leak a raw persistence graph back to the LLM or the client. Keep it clean, keep it governed. If we map out the fail-safes, they are totally comprehensive. Every single blocked, denied, or missing state results in a deliberate,
highly visible outcome with 0 unintended database mutations. Unknown action, action not found. Denied authorization, action denied. It is locked down tight. We only get an action executed state and the resulting application change when the handler actually succeeds.
So, I want to leave you with this provocative architectural question. If your LLM completely fails or goes completely rogue tomorrow, does your application's access policy still protect your data? Well, knowing what we've just seen with AI Fabric, the airtight action registry allow list, those back-end-owned confirmation states, and the strict typed validation gates, the answer is an absolute, undeniable yes. Your application remains in total control.